In today's lesson, we are going to be looking at the midpoint of a line. So this is the first lesson of our next unit, looking at analytic geometry. And this is going to be kind of using the properties of lines to kind of describe geometric properties or geometric figures or geometric shapes. We're just kind of looking at geometry from a more, I guess, analytical viewpoint or more equation-based view. So as a warm-up, really straightforward, right? We have a graph here. We have a line segment goes from -3 to 5, 3. I just want you to find the midpoint. Where is the midpoint? So where's the middle value or the halfway point? So if I'm looking through here, we should find, okay, the midpoint is going to be right here. So that is our midpoint. And this midpoint is the point 1, 3. So now how did we find this? How did we find this midpoint? Well, different ways you could have done it, right? You could have just went through and say, okay, count towards the middle, count towards the middle. That's where we end up. Could you have done it differently? Could you have done it in a more algebraic way? Well, if I look at the coordinates of this middle point, right, they happen to be the same as the y values. Right? And if I look at the x values, they're not the same, but how do I find 1 from 5 and -3? Well, what we could have done is basically find the average of those two values, or basically add them up and divide by 2. So if I'm looking for my midpoint is going to be two values. We're going to take 5 plus -3, divide that by 2, and we're going to take 3 plus 3 and divide that by 2 for the y values. We get 2 divided by 2, and 6 divided by 2, or we get 1 and 3. So not every line that we deal with is going to be a nice straight line that we can just count to the middle or easily see where the middle is. So we might have to use some algebraic formulas to determine where our midpoint is. And that's going to be the focus of the lesson today. Right, so if we're looking for the midpoint of a line, we can actually just use a formula to determine what the midpoint is. And the coordinates of the midpoint of a line segment are the averages of the endpoints of a line segment. So if I look at this line segment, I have point A, which is one end, and point B, which is another. Point A has the coordinates x1, y1. Point B has the coordinates x2, y2. The midpoint in the middle is taking the average of the x and y values. So to find the average, you add the numbers up and divide by how many you have. Or in this case, x1 plus y1 divided by 2. And for the y values, y1 plus y2 divided by 2. Right, so therefore, to find the midpoint given two endpoints, we have to find an x and y coordinate, like we just said, and we can basically find the average of those values using these specific formulas. Again, x1 and x2, y1 and y2 are the coordinates from our points or endpoints. And xm and ym are the coordinates of the midpoint. So let's just go through a quick example. Find the coordinates of the midpoint of a line segment with endpoints A, -9, 3, and B, 5, 7. So if we wanted to, just for visual purposes, we could draw this out. It's going to look something like this, with A being here, -9, 3, and B being here, which is 5, 7. We want to label our points, so x1, y1, x2, y2. Right? Doesn't matter which one's which, as long as we're being consistent. So in this case, we have our two values. So I can go through and find the x value of my midpoint by adding the two x values together. So the x value of the midpoint is going to be x1 plus x2 divided by 2. x1 we have -9 plus x2, which is 5, divided by 2. We have -4 divided by 2, which is -2. So that's one value. Let me just move this down here so we can do them side by side. For my y value, it's going to be the same thing. y1 plus y2 divided by 2. y1 is 3 plus y2, which is 7, divided by 2. 10 divided by 2, or 5. So now with my two values, therefore, the midpoint is -2, 5. So all I'm doing is finding the average of the x values, average of the y values, and just putting them together to make my midpoint, or the coordinates of my midpoint. The next example, one end of a line segment is P, which is -6, 3. So I'm going to put that on this point, -6, 3. The midpoint, M, is 4, -1. And the other endpoint is Q, which we don't know. So how do we find the other endpoint? Well, let's take a look at our formula. Right? So again, if we remember our formula for finding the x value, x value of the midpoint is x1 plus x2 divided by 2. Based off of what I know, I do know that the x value of the midpoint, this is 4. If we just kind of go xm, ym, x1, y1, and q will have an x2, y2. So xm is 4, and that is going to equal, let's plug in our values. I know x1, which is -6. I don't know x2, so I'm going to leave it as x2 divided by 2. Now I have a formula where I can actually go through and calculate what my unknown value is. I'm going to bring the 2 up, and it's going to multiply. So I'm going to get 8 is equal to -6 plus x squared, or x2, not x squared. I'm going to move the 6 over, it becomes +6. So 8 plus 6 is equal to x2. And then I get 14 is equal to x2. Another way you could do it is you could say, okay, well, from -6 to 4, what is that a distance of, or what is that a change of? Well, -6 to 4 is a change of 10. So then a change of 10 going from 4 to the next one would have to be 14. So different ways you could reason through this, but algebraically, this is what we would do. The other method would be kind of going, okay, so if I go from here to here, I'll look at a different way after. We go through this. Our y value, so ym is going to be, again, ym is equal to y1 plus y2 divided by 2. The y value of the midpoint is -1. The y value, or of the first point, endpoint, is 3. 3 plus something divided by 2 equals -1. Bring the 2 up. We're going to multiply. So we get -2 is equal to 3 plus y2. Move the 3 over, it becomes minus. So -2 minus 3 equals y2, or -5 equals y2. So therefore, the endpoint Q is 14, -5. Now that's the algebraic method. I did kind of mention there is another way that you can kind of reason through it. We'll look at that now. Right? So if I have P here, and again it was -6, 3. I have Q here, which we don't know, and we have the midpoint, which is 4, -1. We could look at it and say, I'm just going to move this down. Okay, going from horizontally, or the x value, from P to M, that's a change of +10. So then from the midpoint to Q should also be plus 10. So -6 plus 10 plus 10 gives us 14. We can do the same thing vertically. We're at 3 to go up from 3, or I guess backwards from 3 to -1. I guess these should have been in the other direction. But either way, from 3 to -1 is -4. So if I go down again from -4, or from -1 and go down -4, I end up at -5. So this one is a little bit tricky to visualize because I did, the points are kind of in the wrong spot in terms of visualizing it. But this is another way that we could kind of work through it. If we know what the midpoint is, we know how far the x's changed from the endpoint to the midpoint, and we can then repeat that on the other end to go from the midpoint to the other endpoint. Last example, a circle has a radius with endpoints E, 2, 4, and F, -4, -8. Find the two possible endpoints for the diameter that it contains the radius. So again, remember the radius is from the center out. So there are two possible endpoints here, or two possible circles. Let's just start with one here. So this radius has endpoints E and F. So -4, -8, and oops, backwards. 2, 4, -4, -8. I want to find the radius, or sorry, the diameter. So I need to find, I guess I'm kind of doing this backwards, right? If these are the points here, technically F should be over here. So -4, -8. I want to find the two endpoints of the diameter, so it needs to go something like this, straight through to the end. We'll say this is point G, and it's going to have two unknown x values, or two unknown values, an x and a y. So how we've labeled it here, E is actually our midpoint. It's our midpoint, or the center of the circle. So in this case, we are finding, very similar to the last example, the coordinates for our other point, or other endpoint. So we could do it two different ways. We'll do it algebraically because that is how we want to kind of do it. So the midpoint value is equal to x1 plus x2 divided by 2, or 2 is equal to -4 plus x2 divided by 2. Bring the 2 up, and we multiply, so we get 4 is equal to -4 plus x squared, or it's not x squared, sorry, x2. Move the -4 over, becomes addition. We get 8 is equal to x2. So now I have the x value. For the y value, again, I'm using the midpoint formula. Y1 plus y2 divided by 2. The midpoint we know is 4. The x, or the y1, is -8. So -8 plus y2 divided by 2 is our one side. Move the 2 up. Get rid of that first. So we get 8 is equal to -8 plus y2. Move the 8 over, it becomes addition. We get 16, I believe. 8 plus 8, we get 16 is equal to y2. So that means, therefore, we'll say point G is 8 and 16. So that is the other endpoint of the diameter. Now, there was a hint that there are two possible circles. And the reason being is because E could be the midpoint, or E could be the end point. There is nothing telling us which point is the middle and which point is the end, just that it's the radius. So the radius implies that one of those values is the midpoint, or at the center of our circle. So we did one example where E was the midpoint. The next one we're going to do where F is the midpoint. right? And this is going to give us two different values. I'm going to go through and do the exact same thing to find, we'll say EF, we already did G, let's call it D. So we're trying to find point D. So X midpoint is equal to x1 plus x2 divided by 2. My midpoint is -4. So -4 is equal to 2 plus something divided by 2. Bring the 2 up to multiply. -8 is equal to 2 plus x2. Move the 2 over, it becomes subtraction. We get -10 is equal to x2. So that is the x value of that other endpoint. Do the same thing for y, or the y value of the midpoint formula. So ym is equal to y1 plus y2 divided by 2. We have -8 is equal to 4 plus y2 divided by 2. Again, we bring the 2 up to multiply first. We get -16 is equal to 4 plus y squared. Or y2, again, I keep saying y squared, y2. Move the 4 over, it becomes subtraction. We get -20 is equal to y2. Now that I have an x and a y value, therefore point D, or the other endpoint, is -10, -20. So these three questions are just kind of different scenarios of how we can use the midpoint of a line formula, right? Looking for endpoints of a diameter in a circle, or basically looking for the endpoints given the midpoint and another endpoint. So again, just make sure we're comfortable with that formula and some of the different scenarios that we could come across.